So this is kind of the rough outline of what I'm going to go through. I'm going to spend a little bit of time just talking about why debugging is like a separate mental activity. It's important to think about it like that and develop techniques to do that. And then I'm going to kind of spend probably 7 or 8 slides or so kind of talking about a structured way to go about it. That's kind of like you can think of it as the scientific method, where you like think up hypotheses and test those specific hypotheses. And the hypotheses have to be things that you can disprove. And because we live in the real world, they also have to be things you can disprove in like a finite amount of time, like while you're under pressure trying to debug something, and you refine and repeat that. And then I'm gonna kind of hit a lot of slides that are sort of a list of typical kinds of bugs and clever things you can do to test. But that section is a little bit contradictory to the main thesis there, because you can't debug really just by having a list of every bug that's ever happened and checking them all. For one, you'll be out of a job or lost a client long before you get to the end, and there's always new bugs. Like, you have to actually sort of think and use logic and follow a more structured approach like that most of the time, and you'll find that that's much quicker. But there are a lot of things, a lot of tests that are common and quick to do, and because they're quick to check, they're kind of like checking to see if something is plugged in, and and you should go ahead and do them. So why to focus on debugging? One of the first things to point out is that you do it a lot. Even if you're a very good developer, if you actually sat down and wrote what you were actually doing every 5 minutes, like intensively tracked your time throughout a day or whatever, you would find that a huge portion of your time is not writing new code. It's debugging why the obvious thing didn't work. Programmers sometimes spend a lot of time just reading APIs or trying to figure out if something is even supposed to be possible and that kind of stuff. But a huge chunk of it is debugging. And this is a nice quote that I found. It's from Maurice Wilkes, who's a British guy who was involved in some of the first computer work that was used in decoding the German codes in England during World War II, and then turning some of those facilities into the first computers afterwards. And he, in a biography he wrote, he describes writing the first big stored computer programs and so on. And he mentions that he was writing them on paper tape in an office on one floor, and happened to run down to the basement to run them on a computer, then running back up to his office to fix something and going back down to the computer. And he says that he remembers exactly where he was, like going around and landing on the stairs, going down to run the program one more time, when he realized that a large portion of the rest of his life was going to be spent finding mistakes in his own code. And that is a lot of what debugging is. Unless you work in a unusually large team, or you're some kind of like kind of an integrationist type person, you probably spend most of the debugging you're trying to find your own bugs. And if you think through how to debug as like a thought process, and like there are certain tricks to it, and what kind of bugs you yourself tend to produce and so on, you can get a huge productivity increase. You can make it go a lot faster. And I kind of have my own definition of debugging, and a lot of people kind of include in debugging a big swath of things, including follow-up development and writing documentation and all that kind of stuff. But the part of it that's like mentally different from just writing code in the first place is the part where you're trying to find it and find that understanding. And it's not even so much locating the bug sometimes. Like sometimes you can know that something about this line of code is causing the problem. It's developing an understanding of what's going on. And so kind of going back to the scientific method analogy, like you have a sort of model in your brain of how the code or your website works and where things are fetched for and how they're printed out on the screen. And a bug is when something different is coming out on the screen from what's going on in the model of inside your head. And you have this basic mismatch. And you've found the bug, in my opinion, when you understand something new about the code, or and you realize why it's putting its model now matches. You know why it's putting what it is on the screen. You understand what's going on. A lot of times, once you found the bug, I mean, most bugs are sort of trivial. You realize, oh, I didn't realize that was in the code, and you take something out, and the bug is gone. Other kinds of bugs, and those are sometimes some of the hardest ones to find. Finding the bug is not so much the hard part, and you get to this point where you realize that a big chunk of my system doesn't do what I had previously thought it was supposed to do. It was never designed to do that. And you realize that to fix the bug, you're going to have to do a lot of work or redesign or something. But at that point, you're more kind of like in just development mode. You're thinking about what the code should do in the future and building it to match. It's not this sort of detective process of figuring out why it doesn't match what's already happening. And this is another kind of a thing I throw in there. I think it's very good. I mean, me personally, most of the bugs I'm finding are my own always. And I try to consciously think, these are not like accidents, like nobody tapped the keyboard while I was like in the bathroom or whatever. This is like problems that I put in here. Like every one of these bugs flowed out of my own fingertips, right? And as you kind of wind up the process of debugging, if you remember that, then I think it makes you a better programmer over time, a better developer. And even the kind of the word bug is a little bit like an alibi. It's like pretending that a cosmic ray flipped a bit in memory or something. Like bugs just sort of happen, like they grow like roaches in an old house or something. But they don't. I mean, these are digital systems that pretty much do exactly what we tell them to. Most of the time when there's a problem, it's because we told it to do the wrong thing. And there's a whole class of problems, of course, which aren't like that, disk errors and network errors and so on. I generally use the words when you are finding that as I generally refer to that as troubleshooting, because it's more like a particular instance of something that you're finding a problem in. But it's a lot of times the same mental process. And the truth is, most of the time when you're trying to figure out why something isn't working, you don't know whether you're really debugging or troubleshooting, whether it's something in the code or just with your version of the system. And that's one of the things you have to test and check for. And I put this picture in here. It's from the Wikipedia article on software bugs. And it's generally cited by people as like where the word bug came from. It's an engineer's notepad from when he was working on the ENIAC system. And you see he showed up at work bright and early at 8 a.m. And he says he started running a cosine tape and testing. And there's an ancient piece of yellow Scotch tape. And the note says, relay number 70, panel F, moth in relay. And then he wrote down under here, first actual case of bug being found. Which also kind of contradicts that this is the origin of it. He wouldn't have said first actual case unless programmers were already using the word bug to mean things like this. And I tried to do some internet research and looked up in a couple of jargon dictionaries or whatever and see where the word bug came from. I think it probably came up with people doing technical stuff during World War II. There were references to mechanics using the word gremlin to mean a bug in something that was mechanical, like an airplane engine. But I didn't actually find anybody who said that it came from X place or anything. But if you ever run across anything like that, let me know. I would find that interesting. So here I'm going to get more into sort of the structured process. Usually, when like you're handed a bug, often it's kind of under time-pressing circumstances. Like your boss says the customer is angry about this, and I am too, or something like that, and you want to fix it quickly. Usually, your first instinct is to take a guess at what it might be, change something, and see if it goes away, and then breathe a big sigh of relief if it does. Usually, that might get you out of like immediate hot water, but that usually is not solving the long-term problem unless you can check. So usually, what happens in reality is you try some simple things, sort of your quick and dirty tests, and when they don't work, it's important not to kind of get mired into thinking of weirder and weirder things it could be, and that take longer and longer to check, and pretty soon you're into like a multi-day bug hunting expedition. At some point, you have to kind of say, okay, I'm going to have to debug this. You have to leave me alone. And you kind of start running through this loop of processes. You sort of vacuum up. I kind of have a bunch of information that I collect about the system, gathering initial info of logs, screenshots, getting a correct bug report instead of somebody just telling you something didn't work is a very important part of this. Just making sure they are going to the right server so that you can get logs from the right server and that type of thing is also very important. But this is kind of the point where you kind of have to like, sometimes you have to kind of impose a little bit of discipline on the process if you can, and so on. And then what you start doing is you start making a loop through the steps 2, 3, and 4. Like you say something like to yourself like, we're not running a current database for some reason because of something that happened last week. I think we're running a backup database. And then so that is a hypothesis. And you think, how can I check that? I can look to see if any of the blogs have a date from this week or if the newest one is from last week. And so you have a hypothesis and a test there, and you can go look and then eliminate that hypothesis. You say, no, okay, there's new content. That's not the problem. And it's not a recipe-like process. Like you can't really make. I mean, this 1, 2, 3, 4 like makes it look like there's something like it's just steps you can follow. But each one of these steps is kind of vague and takes like some intuition. So you can learn to do it, especially if you just try and try to get better at it. But it's very hard to just tell someone how to do it. And part of the key is making hypotheses, not that they're just good, like that, hey, this probably is where the problem is. You also have to make hypotheses that you can test. And usually at the first part of the process, you want to make hypotheses that don't exactly guess the problem, but just sort of narrow it down. Like all our IP balancer is not working and all the traffic is going to one server, right? That's a hypothesis, but it's also quick to test. And you want to start making ones that like split the problem down. So like one type of hypothesis would be like that is I think the wrong thing is showing on the screen because something new that someone added to the theme is rewriting it. And then so you go look directly in the database with PHP MySQL and see if the content appears right in the database. And so you've, based on that test, you sort of chopped your problem into two places. Like it can either be in this code or else some content was entered wrong and is wrong in the database. And that divide and conquer and easy tests are sort of the secret behind doing this well. The gathering information part is not trivial. Like you kind of learn how to get good at it. For the particular systems you work on, you should You should learn the location of all the logs, including the ones that you don't have to look at very often, such as the MySQL log or a slow query log for queries that take too long, and things like that. If you have your DB logging so that watchdog messages don't go to the database but go to syslog on your production machines, which is generally a good idea because it's faster. You should have something set up which takes that syslog, which is usually varlog messages, and say like once a night copies it to a Dropbox or something like that where the developers can get to it. So that if people start complaining about something, the development team, which can go look at the logs easily, maybe without even having access to the production server. And so those are sort of like technical development and DevOps type tips, but there's another whole kind of art to the gathering information side that's that's much more human, like social engineering, and that is talking to the person who has reported the problem and getting information out of them. One thing that I usually do if I'm starting a project and I know I'm going to be working with someone for several weeks or months is I find out what type of computer they use, whether it's a Mac or Windows or different computers because they work at an institution or they go around to different places or something like that. And I make sure they know how to take a screenshot and email it to me. Because you can get a lot of contextual information with that. Sometimes somebody will report to you, everything stopped working or something, and you get them to send you a screenshot and you realize that they're using IE instead of Firefox, probably because they're on a different computer, and it looks like they put in the URL to like a demo site you gave them when you were delivering stuff, not the live site, or something like that. Like you can get these sort of contextual information that they're not going to think to give you. And a lot of the times the people that someone reporting a problem first talks to aren't the developers themselves. It depends on whether you're a freelancer or a small shop or you work in a big institution or whatever. But if you're like the project manager or account manager or even a secretary for a small web shop or something like that, there are times when you can really save your organization a lot of money. Like you can save your salary for several months just by developing sort of the manner of being able to sort of politely ask the right questions and get information out of people and get contextual information out of people. Like sometimes like a account manager who visits on site regularly, will know contextual things like at this office they're redoing the network and upgrading everybody's PCs or something like that. And that's not normally something that would just pass through the chain of command or something. But if you're in one of these roles and you think of this as like one of the things I can be good at and really save a lot of money in is collecting kind of peripheral vision type information when problems come in. You can somebody who's good at that can really be worth their weight in gold. So you can't start making these tests if you can't replicate the bug every time. And one thing that's very important not to do is to have a bug on the site, go into your development environment, not really be sure if it's there or not because the bug report isn't clear, but you take a guess and say, hey, they're probably doing X and they expect Y, and so you tweak some setting, push it out to production, and say, okay, I'll see if they keep complaining. That's like a very bad workflow. For one, the loop is very long, and most people who see bugs don't report them, right? They just figure out a workaround or do something else. And so the person who's complaining may not come back to you, and you may think you have fixed something. And you've also made a random change which wasn't sort of purposeful to produce a particular effect, and that may have introduced other bugs, or made something completely different quit working. So and bugs that are hard to replicate are the worst because often all the time is spent trying to figure out a way to get the bug to happen reliably. And the instant at which you get it to happen reliably, all of a sudden you understand it, because now that you can get it to you just immediately understand how it's happening and everything. And I've worked on teams, particularly at one of the pharma companies where I worked with, where there was one guy who, would not be considered a star developer or anything, didn't produce a huge amount of code, and so on. But the one thing this guy was great at was when somebody was reporting some bug that happened once a day or something, this guy could sit down in a corner and start doing various things, taking notes in a notepad so he knew what he had tried, what he hadn't, and come back and say, okay, if you do X, Y, and Z 5 times, on the 5th time this happens, and actually figure that out. And that's very difficult, and but you can get better at it. If you're not really replicating the bug, you should resist just starting to make changes, because in hopes that the complaints go away, because you're probably just introducing more problems, and you're definitely sort of just overlaying wool and so on, and covering up and obfuscating the problem, not clearing it up. And so, you usually there's a bunch of things you can try really fast. Like you usually try these things, like even while you're still on the phone with the person or whatever. And those are clearing all the usual caches. That's a usual suspect. Make sure that the last deployment to the live site actually worked. That everything is sort of in tune and working as expected. That the customer is the person reporting it is going to the right site, and that they know what the expected behavior is. Sometimes they report as a bug something that's supposed to work that way, and they just have not been they've not been in the loop communication-wise. And then there are also things like particularly appearance-based things where it seems like a field is missing. Sometimes it's very, if a CCK field is missing, sometimes it's very quick to change over to the Garland theme and see if it's still missing, which kind of eliminates your custom theme as the problem, and you can change back. And you have to remember that anything you change as a test, you have to be able to undo. You don't want changes to accumulate. On some of the systems I work on, it seems that a common problem is for some reason the CDN has old JavaScript and CSS in it, and the aggregation didn't, the new aggregated files didn't get pushed out right or something like that. And so that's cost me enough time in front-end debugging that it's almost always one of the first things I check to on those ones. And it's hard to have a global list of all these things because all projects behave slightly differently. But you want to kind of remember your previous ones and have a mental or an actual written down list of things to check that are the check the plug type things. Is it even plugged in type stuff, and you'll accumulate those on sort of a per project and per team basis. And I put this in here, and this is particularly useful in Drupal. A lot of times because of a bug seems so weird, like I immediately become engrossed in like trying to compartmentalize it and track it down. This is one step that I tend to forget, and that is that Drupal tends to document its problems more than other places. It's kind of hard to search for them sometimes, but a lot of the really hard problems that you spend 4 or 6 hours working on, you'll find that somebody else already spent those 4 or 6 hours, and there's an issue on D.O and a patch or directions under the issue on how to work around it, or you can go on the IRC channel, Drupal support, and and somebody will explain to you what you're doing wrong, hopefully politely. I find asking on Drupal support is good because when I describe the problem, I use my words and I use the words I'm using to search Google, which are often not the right terms. And other people read those words, they come back and they say, oh, this is working, this is not working, and there's some other word that they're using to describe it, and I paste that into the search, and all of a sudden I'm getting hits. So asking on Drupal support, even if people don't, even if people can't fix the problem, just in the process of talking back and forth with them and describing it, you'll get pointers on how to search better. And another thing that I do to kind of test to see if other people have done it is and this is not usually a first thing. This is kind of a few steps down when I've narrowed it down to some particular module or functionality of the site. I might try the development version of various modules. And this is a test that you want to sort of do on a test system that you can undo by restoring the database and backing out of that, because otherwise you end up updating to the dev version of modules to solve a problem that wasn't the cause of that problem, and you sort of just introduce complexity into the site and the problem. So don't arbitrarily do that, and when you do it, I generally refresh the database back out of the dev version and then test for the bug again, just to make absolutely sure it's there with this version and not there with this other version. And there are also so these sometimes aren't that cheap and easy, but they're common enough that I usually end up falling down and looking to them. Not all of them, some of them don't seem to apply very much with Drupal 7, but are more common with Drupal 6. But just in general, speaking about this whole list, there's an overall thing that I point out, it's that a lot of these common problems deal with permissions on some level, either at the Unix level system, permissions in Drupal, with node access, or content permissions and CCK fields, and that type of thing. The top one, permissions on an input filter, I put it at the top because I've run into this several times, and several times I had forgotten about the previous time and spent a lot of time tracking it down. But it's when somebody goes to edit a node and it says access denied, and it's not because node access or some other part of the system is denying that, or they don't have edit permissions. It's because the input filter that's defined for that content type, like which WYSIWYG they use to fill it out, doesn't have their permissions on it. And so it's like another little corner where there's some permission stuff that have to be tracked down. And so a lot of these are common problems, but a little bit more expensive to do. So you're not going to just do them every time without having a reason to think that that's the problem. And again, you really want to sort of keep your own mental list. Are actually in a notebook. Sometimes on some projects, I have a small dedicated notebook, like a Moleskine or something, just to that project, and something like on the back page, I'll just jot like a one line or just a couple of words about each problem that took a while to fix, that rolled back, and that way I can flip to that and scan through it, and try to avoid, debugging, spending hours finding out that one of these is the problem twice. I mean, once is enough usually. And the rare and obscure problems, I think it's a common mistake for someone debugging, is to remember from other developers like all these sort of war story type things, like really crazy weird things that cause bugs, and start trying to look for similar things in their problem. And those rare and obscure things are very useful, because when talking to more experienced developers, it's a way of sort of passing on bug hunting techniques. But most of them are hard to check for, and so you spend a lot of time checking for something that has a very, very low chance of being your problem. And it also distracts you and just gets you out of thinking about, keeping in right in front of your face what's actually going wrong. And so it's usually a mistake to kind of go down that list. And your list of cheap tests and common bugs and stuff should kind of be short. Like, you should be able to kind of work through them in a half hour or so and say, okay, I need to roll back from the computer a little bit and think about this really hard and think about where it might be and how I can test for that, and get into the cycle of narrowing it down. Yes.
Question.
Yes.
So now it sounds like you've been talking about troubleshooting and debugging if you're the developer writing a module. But what if you are a developer using contributed modules, and I guess the original author just did not have a lot of support, not a lot of logging? What's available to them? Some of the techniques apply, but
right.
some of them having a hard time.
Yes, that's a very good question. The question is, a lot of what I've been talking about is from the point of view of somebody who is the developer and is debugging their own code. And that applies to a lot of the stuff, because I think most of the bugs you're finding are your own mistakes. But inevitably, especially on something like Drupal, where you can end up building most of the sites you want to build without ever writing any code, you end up debugging something that's from a contrib module that's not your part of the code. And most of these techniques apply, but they have this sort of additional overhead that you have to understand that code. So it's not, and I would also say that once you're using contrib modules, the bugs tend to be more often that you are not understanding what the original author intended. And that's not necessarily your fault, because a lot of times it's just a documentation fault. Like, they didn't exactly express that actually I'm only trying to solve this narrow problem and not this big problem. And so I think one of the things when working with contrib modules to go far quickly is to go out to the Drupal support IRC or to this UQ and try to see if other people are using the module in exactly the same way you are, and if there are a lot of other people using it, because that will give you a clue if you should even expect it to work, right? And then if you follow down the path and start having to actually debug someone else's module, it's pretty much the same, but you have this sort of pause where you stop and you read through their code. And I usually read through their code, like look in all the files, even if it implements like default views, I take a glance at those even if I'm not using those. And then I also just go to the project on Drupal.org and I scan through the currently open issues. And I'm not just looking for my problem there, I'm looking to see if people are currently using the module and reporting problems and solving them, like if it's in active development. And if the last thing that happened was several years ago, I kind of get worried. It may be that it works perfectly and I finally found the one last bug, but it might be that everybody else has a different module they use to solve this problem. Maybe I should go back to Drupal support and say, hey, I'm using this module, it looks kind of dead. Is there another module everybody's using these days? And go from there. In that case, you won't find the bug, you just find a different way to do it. So that's a very good question. I think as Drupal kind of matures and people make more sites without custom code, that's going to become a lot of the troubleshooting you do. So this slide sort of covers like the basic ways to sort of peer into the system, because like all of these tests, you you have to have some way to actually take the measurement. You know, if you think of the scientific method analogy, this is equivalent of having the microscope, or, you know, having the neutron detector or something like that, like some way to see into the system beyond what just displays on the web page. And if you haven't, I definitely think you should check out the Devel module and its CRUMO functions and how you can use it to like print out a whole array in sort of an expandable, browsable way. I actually often use what most people consider the primitive print method, where I just go in the code and I print out the variables that I'm trying to track at different places. And I usually wrap them in pre-tags so they'll show up on the page without messing up everything. And I'll use the print R function if I want to dump out a whole array expanded. And you can't do that with a giant object, but I feel that sort of encourages you to kind of think for exactly what you're looking for. That's going to be different. Like, you know, what is the piece of information, the variable or the flag in the system that's wrong, and, you know, hypothesize on what that should be and print out just that. And you can use Watchdog, or there's also other little logging functions that'll dump to a file if you're debugging something that runs inside a cron hook, or say inside a batch process, so you're not gonna get things out to the screen as easily. And the next point I wanted to make was more about the fancy tools, like being able to use Xdebug integrated with your IDE, so you can step through the code and see all the values as you go. That's a very useful thing to have set up, and it can be very valuable, but you should do it before you have somebody complain to you on the phone about it, because for one, it can be kind of intricate, especially getting, you know, the ports right to some other server if you're not running it on local or something like that. But it's also not going to just automatically make you be able to solve all bugs. I've stepped through code which had a bug in it, like, and looked at every line and read the line, understood what it was doing, looked at the variables or whatever, and come out at the end and had the result appear up on the page, and the bug is still there, of course, and I watched it happen in slow motion, and, you know, I still don't understand it. You know, just because you have the tool doesn't necessarily give you that insight. And I make this analogy that some people who are into golf make, that, you know, most people who want to improve their golf score, if they're going to spend, say, $400 and, you know, try to get better at golf, they're much better off spending $400 to take a few weekends of lessons from a pro somewhere at a golf course than they are spending $400 to get the latest set of clubs. Because most of the time what's holding you back is you, not your tools. And there's kind of an analogy here. Most of the time you can get much better at debugging by thinking about the process really, really hard and making very, very clever guesses that are sort of matched to good tests to try, than by, you know, having the latest whiz-bang tools. That said, if you set up Xdebug and all that, and if you're doing a lot of development, you probably should, try to make it standard on everybody's that you work with environment, so that when they're seeing something, you don't have to get their code and then see if it also does it in the debugger, like, and sort of make it part of your routine process. And you generally never leave that kind of stuff turned on a production server, but you should have it set up so that you can turn it on and do it on the live server if you have to, and so that if you decide that you need to, like, there's not an hour wasted trying to figure out how to set that up. Yes?
One thing I've noticed, that even if you don't use the Xdebug tools, you can enable the Xdebug in PHP, and it'll give you better errors coming back when you have PHP errors. It'll do a little bit of backtracing and show you a little nicer error than the normal white screen of death.
That's a very good observation. He's pointing out that even if you don't set up the IDE integrations that you can step through and everything, if you enable Xdebug in PHP, then you get better error reporting out of PHP in the logs. And and that's a very good point. It hadn't really occurred to me, probably because I have it on in most of my environments except for the production ones. I would just add to that there's performance and possibly security reasons not to leave it on a production environment, because it's normally, it can be set up so it's listening on a port that the IDE connects to. And if you have a server out there on the internet that has that port open, somebody could connect to it and essentially be inside your PHP process doing whatever, read out a dump of the database or anything. But that's a good point. Just enabling Xdebug gives you better error reporting, which is usually jumps you past the first 5 to 30 minutes of working on a bug. Because getting from the white screen to having your first actual text message is sometimes like a kind of a process.
Robert, can I ask what IDEs others use or are available?
That's a great question. The question is what IDEs other people use and what's available. I tend to, and this is mainly because of my background and where I come from as a developer and so on, I tend to go very, very simple and use VI or Emacs and not have it very integrated, and then use something with Xdebug integrated when I have to do that task. It seems that a lot of people are leaning toward using either Eclipse or NetBeans. Those are two IDEs that a lot of people have gone towards. And I mentioned at the end of this point, try the Quick Start project. If you go to drupal.org/projects/quickstart, there's a link there to a VirtualBox virtual image that you can download and then run on your laptop. And this Drupal developer named Michael Cole has set this up, and it's a Linux machine that has all the various tools like Xdebug and the integrated IDE and all that kind of stuff, all sort of set into it and already built up, so that you can download this and just use it. And it has a lot of other stuff that really helps with your workflow too. Like if you are starting a new project and you want to start up a new local site, there's just a little Drush script. It's like Drush quick start new site, and you give it a domain name like mycustomer.local, and it automatically grabs a fresh copy of Drupal, either 6 or 7 according to what you tell it to do, puts it in the right place, sets up your host file, and does all that stuff for you, so that you're sort of automatically at a fresh start point. And it has, I think, both the NetBeans and Eclipse installed. I think the NetBeans is the one that's configured by default. One of the things that I wanted to do with this presentation as it evolved is I was hoping to have that running and kind of at the end of it go in and demo that tool using Michael Cole's Quick Start image. And unfortunately, it wasn't quite working right, so I didn't stick in that little demo at the end. But that's definitely a good thing, and it leads into what I'm going to talk about in a slide or two about the Devel module, which also kind of shows the Devel module sort of encapsulates a lot of the problems and techniques other people have had before. So part of inspection, just leading from that previous slide, is there's inspection in terms of looking into the running code and seeing what variables are in the process of generating a page or doing anything else. There's also inspection in terms of looking at the database, and oftentimes I've had people say, hey, my site was working and I applied these changes or these updates and now it's not working. I want to take the 2 database dumps and diff them and see what the change is in the database. And it's just hard to do that because of the structure of an SQL dump. I've tried to do it before though. But one thing you can do is if you do drush vget, it'll just print out everything in the variable table, and you can dump that to a file and then go to your other database and dump that to a file. and diff those, and you'll get a little bit better output. And since most of the modules set key parts of their configuration variables, you can often quickly zoom in on something to look at. But the database is so big and has so much stuff that extraneously changes, like the modified dates of content and stuff like that. You can't really just blindly compare it. You have to, again, you have to have a guess of where the problem is or what's causing it, and go look for that specific thing. And so getting back to the devel tools thing, the devel module in Drupal is a good thing to look through if you're trying to become a better debugger or just general developer. And the reason why is it contains all these little submodules that do things like put up a block that shows the node access reasons why you could or couldn't access this particular page, right? And it has a user switcher so that you can switch to another user kind of on the fly. And you know, you can list all the MySQL queries that ran to generate this page. And so those features are kind of a way of seeing like what the other developers of Drupal over the process of time have, like all the common problems they have. Like this is sort of like a distillation of their experience, because these are the tools that they found useful enough that they ended up being in the devel module. And so even if, you know, just scanning through that and seeing that is you know, sort of a way of you know, stealing some of their experience and seeing the things that they have done. Another thing I mentioned, although like Xdebug, it's a security risk or whatever, but sometimes in the process of debugging or in just ordinary development, if you have the devel module turned on, you can go to your site /devel/php, and you get a text box where you can input PHP code and click eval, and it will run in the Drupal bootstrapped mode. So you can do quick things in there and kind of use that both as a development and as a debugging tool. I've used it. I've done DB query and put SQL queries in there and printed them out. Often there's a tendency you want to use this on a machine where you don't have command line access to the database or something like that, but don't use it as like a way to get around restrictions on a production server. Turning this on a production server is generally not really a good thing to do. I mean, only admin can get to it, but I usually leave the devel module turned off on all the production stuff and do that only in development. So I tend to, and a lot of the debugging I do, just because of the role that I do, you know, I kind of narrow it down to being in the theme, and then I end up handing it off to a front-end person. So I have less experience debugging theme type stuff. I put this question mark by this top one because I was going to remove that, because I don't think that one applies to Drupal 6 or 7 anymore. But it used to be that when you had like if you go to the views theme hints, and it has that hierarchy of template files that you can do to theme something to a narrower and narrower application. If something was missing along that change, it wouldn't go all the way down. But I think that's been fixed. The devel module has a themer module, and there are several other tools as well, like Firefox extensions and so on, that are really good. One of the things that's bitten me before is the IE thing, where it won't read more than 31 CSS files, and then it chops out. And so if you, quick way to test for that is to make sure that CSS aggregation is on. If you're seeing problems in IE and CSS aggregation is off, that very, very well might be the problem. And there's the form alters, and in general, it's kind of a wrap-up point. You know, in going between different browsers and just kind of web development in general. Things like topography and color profiles and that kind of stuff can often be really different. And that is a whole area of debugging in and of itself. And another area of debugging that a lot of developers are a little bit less familiar with is the performance type things. And I think a lot of times, people have developed and delivered some website, and then it's out there for weeks or months, and runs into problems. And the problems with a lot of developers when they run into performance problems is they're not used to going through the same cycle of being able to replicate the problem, check for information, and then do those kinds of things, because they're not used to replicating performance problems, and so they tend to fall back into making a change, pushing it, and hoping that the complaints stop coming. And so if you're going to be faced with performance problems, learning how to replicate them using this AB tool or the wget command with the -r and that kind of thing is key. Then the MySQL logs and OTOP, which will list the current MySQL queries running, are the next key, because they're kind of in the performance world, they're the equivalent of printing out variables. They're like your ways of seeing into how the system is going. I mentioned this trick that if you're doing custom code, you can print out different headers depending on whether a cache is being hit or not, and then use that to see kind of what your hit rate is on certain things, and should you expect something to be fast. And then XHProf is sort of the equivalent of XDebug. It's sort of the performance tree of where you're going to the most functions. And the same things apply in that you have to be able to replicate it. The fancy tools don't help as much as thinking about the problem hard. But just because it's a performance problem, don't get out of the debugging mode. And this is kind of one of my final wrap-up slides. The bugs that are the hardest, that will be the most frustrating, are kind of be bugs that resist being compartmentalized by being split. It's sort of an interaction that this theme works everywhere normally, and this module works everywhere normally, but the two together for some reason have a problem. And those are going to be the things that really kind of get to you. And some examples of where those things can come into is like module waits, like hooks being run in different orders just because the modules have different installation rates. A lot of interaction things come up, of course, with external stuff like pulling something from some service when you don't understand the API, or maybe you don't understand the API because they never really documented it. It seems to be kind of common. But if you're working on a bug and it's resisting being like compartmentalized to a specific area, then kind of step back a moment, because that's going to be the hardest stuff. I've done read a lot of different books about debugging. If you search on Amazon, you find a lot of references to sort of scholarly and academic type books. A lot of them are sort of grad school research type things on automatic debugging systems and so on. And none of them are really very useful. This is the only one that I would recommend you spend money on if you want to get good at debugging. And it's a very sort of humorous, informal type book. The guy breaks his thing down into 9 rules, which kind of roughly are analogous to the various things I said, like make it fail, being you have to replicate it and so on. And I have a couple of copies of that up here. If anybody wants to look at it afterwards. It has a website. It's debuggingrules.com. And the book is a pretty thin paperback and not that expensive. And there are a lot of much thicker hardback, software engineering type books that are not worth as much money as this pretty simple one. And so that kind of wraps it up, I think. The main conclusion, the main goal is to sort of have a structure of making guesses, narrowing things down, and making guesses such that you can test them. And that will get you a lot further than turning a fire hose of fancy tools and techniques at the problem. And the hardest ones will be the ones that are interacting between several different bug-free portions of the system. And so it's like some basic interaction between two things. I think getting back to one of the questions we had, a lot of those will almost always be things that different people have written, i.e. different contrib modules where the people who wrote those never even considered them operating with each other. And one of the key things is that if you just think of debugging as being a separate mental task from development, and you consider it as something that I can be good at or I can be bad at and so on, and you kind of get in that mental thought process, I think you'll get a lot better at it. And how much time do we have left? Okay, so we're out of time, but I have those books up here, and we're going to have a BOF on this sometime this afternoon for some of the people who didn't get in here. So if you want to ask me questions in the hallway or come to the BOF session, then we can talk further.